Alright, and then we get to a pretty ugly one here. This one's going to involve a lot of our properties, and that's why I went with this one as the last one here. So when you look at this guy, you've got this whole parentheses squared. So what you want to do is you want to square everything in that parentheses. But make sure there's no addition or subtraction. Remember, our rules don't work if there's adding or subtracting on the inside, only if it's multiplication or division like you have here. So we can take that 2 and we can square it. When we square the 2, it's going to be 4. This is x squared already, and then when we square it again, remember when you raise an exponent to another exponent, you multiply the exponents. So x squared becomes x to the 4th, because x squared, when you square it, is x squared times x squared, which is x to the 4th. Then you square the y, and that one's easy. It's just going to be y squared. On the bottom, you square the x, and so it'll be x squared. Now, we could go with our division property like we did back here on this guy, but I'm going to wait on that because I like to wait and do that after I've multiplied it by this other fraction. So I'm going to do this other fraction first. So I'm going to take 3 and I'm going to cube it. So 3 cubed is 27. X squared, and then cube it, so multiply your exponents because you raise a power to a power, you multiply. So 2 times 3, that's going to be x to the 6th power. Then you have z to the 3rd. On the bottom, you've got 2 raised to the 3rd power, so that's going to be 8. Y to the 3rd power is going to be y to the 3rd. Then you have z squared. Remember, raise a power to a power, you multiply. So 2 times 3 is going to be z to the 6th. And then what I like to do is I like to multiply straight across the top, straight across the bottom, because what that's going to help me do is get it to one big fraction, and then I do my division properties like we did up here. So I take and I multiply 4 times this 27. So when I do 4 times 27, you're going to end up with 108. Then I do x to the 4th times x to the 6th. Remember, multiply like bases, you add the exponents. So what is 4 plus 6? It's 10, so that's x to the 10th power. Y squared, there's no y over here, so you just write it out. And then you have z to the 3rd over here, but no z over here, so you just write it out in alphabetical order, x, y, and z. Then on the bottom, I've got the 8 times a 1 that would be sitting in front of that, so it's just going to be 8. And we'll reduce that fraction in a second. X squared, y cubed, and z to the 6th. There's no like bases, so all you can do is just rewrite them. But now you can do your division properties. Like we said, you subtract. But one of the things I didn't talk about up here because it didn't happen is the bigger one was on the top when we subtracted 2 minus 1, so that's why we ended up with a positive 1, and the y is still on top of a over 1 like this. But when we look at this, we're going to have some that are on the bottom that are bigger than the ones on the top. The y to the 3rd is bigger than y squared. Z to the 6th is bigger than z to the 3rd. So that means they're going to stay down here. Remember, that was a shortcut that I showed you. So when you take 108 and 8 and you simplify those fractions, both of those right there can be simplified because you can divide that, both of those by 4 there. And so that's going to give you 27 over 2 is what it reduces to. X to the 10th, 10 minus 2 is going to be 8. And since the bigger one's on the top, the x to the 8th is going to be on the top. And you have y squared and y to the 3rd. The bigger one's on the bottom. 3 minus 2 is going to be 1, but it's going to be y to the 1st on the bottom. Z to the 6th, z to the 3rd. The bigger one's on the bottom, so 6 minus 3 is 3. So z to the 3rd.